Hello everyone, welcome back to Analytical Guy. In our previous video, we explored how to create a dynamic teams point table using DAX in Power BI. In today's video, we will take a step further and discuss about batting statistics. So in case you want to rank all the players on the basis of runs or on the basis of batting average or strike rate, you can do that. We will also calculate total runs, create insights that bring your cricket data into life. So let's get started. As you can see on the screen, we have this table with all the players listed on the basis of total runs scored. So we can see the number one player on the basis of most runs scored in Test career is Sachin Tendulkar, and he's from country India. Second is Ricky Ponting, and the country is Australia. You can see Sachin Tendulkar scored total runs of 15,921. Ricky Ponting is ranked 2 and has scored 13,378 runs. And we can see all other players. We can sort this on the basis of team. For example, I want to see all the players from Team Australia. So I can filter Australia. I can see the rank of Ricky Ponting is rank 2 because one is Sachin Tendulkar. Then there is no one in top 10. Then 11th ranking is Alan Border. So Alan Border is number 2 player in Australia. Then we have Steve Waugh, then Steve Smith with rankings 15 right now. So currently this statistics has been updated until 1st of July 2024. So we have seen Steve Smith scoring more runs in BJT for against India. So for sure he's still ranked 4, but he might surpass Steve Waugh in near future. So this is how we can have this table. So we have ranking, we have span, like from which year to which year the player has played, number of matches played, number of innings played, not outs, runs, highest score, averages, balls faced, strike rate, number of hundreds scored, number of 50s, number of ducks, number of fours, number of sixes. So we will create this table in this video and understand how to do this dynamic ranking, because if you do a straightforward ranking, you will see that Ricky Ponting will be ranked number 1, Alan Border 2, 3, because whenever you use sort this or filter on the base of team or anything else, this ranking will change. So you can see Bangladesh, when I sort this on the team Bangladesh, rank 82 is the highest for them, is Mushfiqur Rahim. And if I did the normal ranking, this rank would be 1 because in Bangladesh, Rahim is number 1, right? So we will do these kind of calculations. Also, we will try to work on the strike rate versus batting average. That is, if we go to page 2. So if you have to compare the batting statistics for one country versus another, we will do this as well. So getting back to the first task. Now, in this table, you can see the ranking is there, right? So if I go back to team, let's say India this time, and rank 1 is Sachin, the rank 4 is Rahul Dravid, then rank 13 is Sunil Gavaskar, then Virat Kohli, VVS Lakshman, Virendra Sehwag. So this is the ranking I want, right? How can I do that? So I'll just go to the ranking which I have used here. So this is tick mark. So that means if I've selected this visual, this is the measure used in this particular visual. So I'll just click here, new rank player. And this is the measure I have used, DAX measure. So first of all, RANKX. So whenever you do RANKX, then you have to have a first parameter as your table, then the expression, and then we will also do the sorting, ascending or descending, and dense. I have explained the concept of RANKX in the previous video, so in case you want to understand more in that, you can watch that video. In this video, I'll just briefly show you the use case of this. So now here, I have applied all function. So all function, what it does is whatever is the filter applied, it just negates that, and it consider everything while doing the ranking. Then what I'm saying is calculate this rank on the basis of total run scored. And I am saying remove the filters on player info. So I don't want any filter. And then descending. So high, more the runs, the ranking should be low. I mean, if the runs are scored like 15,000 in case of Sachin Tendulkar, the ranking is number one, right? So that is descending. And dense is used in case there are ties and all those things. So you can decide which one do you want to use for that, right? So this is how ranking is done. So you can just pause the video and just see how it goes. Also, the best scenario for me is whenever you're not able to understand any particular logic, just copy that formula or DAX from measure here and paste it into chat GPT or other GPT and just try to ask GPT engine that, hey, can you please explain me step by step or maybe line by line how this is done? So you will get a better understanding on that. All right, so now let's go one by one. So number of matches, it is straightforward. So I'll just say distinct count of the matches. So if I go back to the table batting card, so this is my match ID. So for any player, so for example, let's keep it easy. This person, batsman one, so he has played, if I select match ID, and there are six filtered rows and there are three distinct values you can see here, right? So 97, 98, and 96. So he played three matches only. So what I'll do is distinct count of match ID. That will be my total matches. So if I go here and see total matches played, so distinct count of match ID, straightforward. How about innings? So number of innings would be this one. So count of all the innings, but there is a catch. So if you go here and see the measure that has been applied here, total innings. So all I'm saying is total innings played is calculate count of all the innings, no distinct count. It is total count. So you have to count 1 plus 1 2, that will be two counts, not one. So don't do distinct count, so I have to count all. So in this case there will be six innings, but in case wicket type is did not bat, DNB, that means he did not play that innings, right? So in that case I have to filter that record. So if I go back to total innings, so I have to calculate all the records, but where the wicket type is did not bat, I don't have to include that. So I'm saying where the wicket type is did not bat, don't include. So count all where it is not equal to DNB. So whenever we have to do not equal to, we will use these symbols to say not equal to. All right. So this is my total innings. Now not outs. So if I say not out, oops, here you can see it is total innings minus total outs. Straightforward. Number of innings played minus total outs will be definitely a not out, right? So how to calculate total outs? Total outs can be easily calculated from is out column. So whenever it is true, that means it is out. So I'll count all the innings, filtering all is out. So if I say total outs, so calculate total innings, that has been calculated already, but filter is out is equal to true. So whenever is out is equal to true, calculate that, otherwise don't. So now we have understood total matches. Now we have understood total innings, not outs. Let's get to number of runs. And this is also straightforward. I'll just do the sum of all the runs column in the batting card. If I go back to the batting card, I have this runs column. So if I sum this, that will be my total runs for that particular player. What is the highest score? So that is where I have to use my max. So if I use max on the runs, that will be the highest score for that particular player, because the context is row context. So whenever there is a player, different player in different rows, right? So it is already filtered for Sachin. So for example, if this is my holistic data set and I filter for Sachin, then I'll do the max of this particular column, whatever is the maximum number run, I'll display it here. Then comes the next second player, that is Rahul Dravid. Then the filter will be on that particular player itself, and the whatever is the maximum number of runs scored, that will come over here. So this is how it will work. Now coming to the averages. So batting average, logically, it is total runs divided by total outs. So if I go here Batting average is total runs scored divided by total outs. So let's say if there is a batsman who uh, was never out, then the batting average is the total number of runs scored. That is highly unlikely, but that is the logic. So we want to get total runs. We have already calculated that. So if you go here, batting average. So we know total runs. We also know total outs. So we can just calculate this divided by this. But we have applied if error. But in case the total outs is zero, then this expression won't be calculated. That is infinity, right? Anything divided by zero is infinity. So what I'm saying is, if this expression give error, then give me zero. So if error, this expression, comma, zero. So this is how you will calculate batting average. Now coming to balls phased, it is straightforward. It is the count of the balls column. So just do the sum, not count. Sum of all the values in this column will be total balls phased. So we can see that. Is it BF or balls played? Yeah. So this is sum of custom balls. So what is custom balls here? Okay, so this is my column here. Let's see. Okay. So see, the custom balls here, I have done some editing in Power Query. Reason is, if you see here, in this particular inning, for a particular batsman, he scored some runs, but there is no balls faced. That is impossible because you have to face some balls to score runs. And that too, scoring 165 runs for zero balls is impossible, right? So there are some of the values which are missing in our data set. So what I have done is, I have done uh, some calculations to get the averages of the balls so that we can calculate some estimated total balls faced. It's not like we have to calculate that way. So there is some weightage on the basis of which I have calculated. So for 10 runs, number of balls faced is 12. For 15, it is 19. For 4 runs, it was already 10. For 165 balls faced for 206. So I will show you the calculations in Power Query for this as well. But just in case you see if any particular column which is important and has missing values, just apply a particular method to clean that data. And in this case, I'll use this column to showcase total number of balls faced. And this is how I can get the averages. So number of balls faced is done. And now I'll go to strike rate. So strike rate, what is the strike rate? Strike rate is number of runs scored divided by balls played. Simple. So if you are scoring 100 runs in 100 balls, that is 100 strike rate, which is really good. In test matches, it is highly unlikely to get 100 strike rate in the span of, let's say, 50 or 100 matches. It is highly unlikely. So in this formula, you can see here, if I just clean that, so I'm saying if this expression, otherwise this, else, sorry, this. So now here, what exactly is happening? So I'll also have this, yeah. So what I'm saying is, calculate total runs divided by total balls multiplied by 100. So this is my formula. But here, what happened is, there were a couple of players whose strike rate was going beyond 500, and which is impossible. So maybe there was one person who scored 5 runs on one ball, like but it is highly unlikely. Again, maybe couple of records, there were balls missing or something, because of which total runs skyrocketed and balls played were less. And the division of runs divided by balls was greater than 500. So in that case, I've made them 0. So this is not relevant because these are not for highest scoring players, and we are predominantly looking for top scorers and players who make significant impact on cricket, right? So what I've done is for all those players, I've made it 0. Otherwise, take this formula straightforward. So it is easy, total runs divided by balls played. And I want to do that in multiplication of 100. So multiplied by 100. That's it. So this is how I'll calculate the strike rate and hundreds. So hundreds is also easy because we have that column. So if you see here in runs, so anything which is greater than 100 is 100, right? So if I go here, the formula would be count of all the innings where the runs is greater than equal to 100. So that will be 100. And similarly with 50, where runs is greater than equal to 50. But I don't want to calculate anything which is greater than 100 in 50s, right? So it will be slightly different. So let's go to 50s. So here, what I've done is calculate all the innings where the batting runs is greater than equal to 50. This is not correct. So if you see here, I have included anything which is greater than 100 in 50s as well, right? So those are already included in hundreds. So what I can do here is, if I have to calculate total 50s, so that would be anything between 50, inclusive of 50, and less than 100. So I can say greater than equal to 50 and test betting card runs. Where is my runs? So this is less than 100. So if you see now, my 50s are 68 for Sachin Tendulkar. 51 is hundreds, 68 50s. Because if you see here, now this will give me all the innings where the runs are greater than equal to 50 and less than 100. Because if the score is, let's say, 120, that is already counted in hundreds, right? That won't be counted in 50s. So this is how you can calculate hundreds and 50s. In case of zeros, it is also straightforward. It will be just count of all the innings where runs is equal to 0 and out is equal to true. Because if you don't include out is equal to true, that means 0 not out is also included in zeros. The player is not out, so you have to exclude that. Only if the player is out, you have to include in zeros. So that is runs is equal to exactly 0, not greater or less than equal to. It is equal to 0 and is true is equal to true. This is how you will calculate zeros. Number of fours. So now I have the column for this. If I go to betting card, number of fours, 16s, I can easily do the sum on it. So if I go here, fours, so I'll just do sum of all the fours, that is fours, and in six it is again sum of sixes. So this is how I'll calculate all these columns. So yeah, so this is how we can grab that. Also, so you can see here we have images. So if I go to visualization, so this is my images coming from image underscore URL, image underscore URL. So if you see here, data category is image URL. So whenever you have this, so if I go back to pair info, so if I go to players underscore info, image underscore URL, so this is how my values are, right? And this is my JPG. So if you see here, this is .jpg. So for JPG, now this my column image underscore URL should be shown as image URL in the Power BI. It should be understandable by Power BI. So what I'll do is in data category, select image URL. Once you select image URL, this will be treated as URL of the image, and you can easily embed that in the visual. And this is how you will see the images of the players. But you should have the URLs for the players, otherwise you won't get that. right? Now, if you just filter out particular team, and then you can see the players on that basis, right? Now, if you want to sort this on the base, if you want to see the player with the maximum sixes, let's sort this on the sixes, and you will see number one is Ben Stokes with 128 sixes in his 102 matches. And then second is Brandon McCullum from New Zealand, 107 sixes. Then Adam Gilchrist, one of my favorites, with 100 sixes. Then Chris Gale, Jack Callis, and then Virendra Sehwag on number six. So this is how you can sort this and see. Also, I want to see the best strike rate of the players. So who has the best strike rate in test match? So if I sort this, it won't give me the correct way, because highest strike rate is 156 for Monty Bowden, but he just played 2 innings. So who gives uh, the best analysis? So I want the significant players, and then see the strike rate for them. So maybe what I can do is I can filter this table with the runs, maybe runs more than 5,000. Only those players will be uh, eligible to see the strike rates. So what I can do is select the visual, go to view, and then go to filters. And in runs, what I can do is maybe greater than equal to 5,000. So any player who has scored more than 5,000 total runs in their career will be eligible to see their strike rates. And the best strike rate would be for Virendra Sehwag with 82.23. He has scored 8,586 runs when he has faced balls like 10,000 odd. It's amazing the way he has played, the way he has revolutionized the test cricket. And number two is uh, Adam Gilchrist with 81.96. So they are quite similar. We can see the run scored is different, but the way they play is quite similar. And we can see number of sixes by Sehwag is 91, by Gilchrist is 100. So yeah, so this is how we can create this table. Now let's try to understand the comparison between strike rates and averages. So if I just go to strike rates and averages, so my first box is for country one, second box is for country two. If I want to compare the strike rates and the batting averages for one country versus another, so let's see here. Let me just remove the filter and make it bigger. So now if you see here, this first visual, it gives me the batting stats, that is strike rate and average. So if you see x-axis, it is the strike rate, and the y-axis is batting average. So you can see most of the clutter is somewhere around here, with the strike rate between 40 to 60 odd strike rate, right? And the batting average will go from 40 to, let's say, 50 or 55. So this is the clutter where most of the players are. And you can see there is one outlier, that is Virendra Sehwag. He has amazing batting average somewhere around 49, with the strike rate of more than 80. So this is outstanding from test cricket perspective. So anything which is above 70 is amazing strike rate in test cricket when you're scoring more runs, right? So if you go back to the report and see the same statistics for Pakistan, for example, you will see here the clutter is mostly here below 60 strike rate, and the batting average is between 42 to 50, 52. You can see this is the predominantly the more famous zone, and wherein this Sehwag is an outlier. Let's say if I switch to Australia instead of Pakistan, and we can see the similar clutter, but there is one outlier again, which is not exactly outlier, but somewhere outside that cluster or clutter that we are saying. That is David Warner. So if you see here, for David Warner, the strike rate is above 70 and average is 44, which is not bad again. So he has scored 8,786 runs with the average of 44.6 in 205 innings. So that is amazing, right? But if you want to see the best batting average, that is for Ricky Ponting, we can see here the average is 51.85 with the strike rate of 58.72. And if we say Matthew Eden is not that bad as well, so strike rate of 60 and average is 50. So he's also amazing cricketer, one of my favorite. Now, if you see here, if I want to go to New Zealand, for example, instead of India, so you will see here there are very less players in this cluster. Also, Kane Williamson has amazing batting average that is of 54.99 with strike rate of 51.41. Ross Taylor has slightly better strike rate with less batting average. I'm curious to see where is Brandon McCullum here. So we can see here, so for example, if I go back to top scorers and I want to see where is Brandon McCullum. So you'll see the average is 38.64 and strike rate is 64.6. So somewhere around 38 is the average. So if I go back to strike rate versus average, and here, if you see, my average starts from 40. So this is where you have to understand how to start your axis. So if I go to visualization, if I go here in y-axis, I am starting from 40, right? So this is up to you if you want to start from 0 or if you want to start from 30. So but keep the same axis for both so that you can compare accurately. Otherwise, if you are comparing, if you're doing it from 30 in the first graph and 40 in the second, so the comparison doesn't make any sense, right? So now if you make it minimum as 30, you can see Brandon McCullum is coming here, right? So this is up to you if you want to make it 0 uh, to max 55 and in x-axis as well starting from 0. So this is how you can do, and same with this. So if I go here, where is my range? 0. All right, so this is from 0 to 0. Now this is my cluster. Now if I go to, let's say, India, now you will see this is not amazing the way I wanted to depict. That's why, because these areas which is less than 40 in both the x and y axis is blank. That's the reason, because in test match and if you're comparing top scorers, it will be the averages would be greater than 40 and strike rate also will be greater than 40. So start your axis from 40. That will be easier to understand and compare the players, right? But it is up to the person and the end user how they want to perceive the dashboard. So just understand their understanding and their criteria while you are preparing your dashboards, right? So this is what I wanted to show you in strike rate and averages. In the next video, I'll explain you how to create cumulative runs, and this is very important. Like if you want to show the milestones when a particular player scored 1000, when he scored 2000, 3000, 4000, in what year they achieved and how they achieved, what is the trajectory, and how to create that cumulative score. For example, in 1999 he scored 440 runs, in 2000 he scored 343 runs, but total runs scored when he completed 2000 was 440 plus 340, that is 783, right? So this is what I'll explain in the next video with the milestone in the consideration. All right, guys. So thanks a lot for watching this video. In case you're facing any challenge while working on DAX, please comment below and I will be happy to assist you to explain and go beyond that point. Also, it is a very important concept while working on Power BI. So try to spend more time on DAX, data modeling, and working on the back end of Power BI. Thanks a lot for watching this video.